And welcome everybody to the Daily Space Weather here at the Smash News Network, least busted name in news, as we bring you the most comprehensive space weather and detailed imagery of the sun you'll find in the known universe. And thanks for stargazing with us. We're starting out with the GOES-R 195 angstroms wavelength, a spectacular wavelength. And don't worry, folks, the sun didn't suddenly rotate like that. The spacecraft did. And we've got diminishing sunspots, diminishing solar activity in general. Let's take a look at some specific features. We'll bring up 171 plus 131 angstroms. This is also a 24-hour video. And let's take a look at some individual areas that we talked about yesterday. First of all, we've got a diminishing probability of large flares coming from this active region. It did already produce an X-class flare and at least one M-class flare. The likelihood of that producing large flares is dropping by the minute. North of it is another active region, a series of decent-sized sunspots that are also setting. Their likelihood of producing large flares still remains, although their likelihood is diminishing as well. If we look up in the northeastern limb, we do have an active region that just rose up here. It is not a sunspot, it's just a plage. And down in the southeast, we do have a new sunspot. So there's a new sunspot, this area right here that just rose. That is indeed a new sunspot. That should get a name today, although it's looking fairly unremarkable. We'll talk about its magnetic fields just before transitioning to our meteorology portion. So that's what's going on. Here's a full disk view. Again, we've got significant downtick in solar activity here once again since yesterday. That's yesterday plus today on the SDO intensity gram. Here is the same time frame on the colorized magnetogram. Only one new named sunspot group today, and a bunch of groups are setting. So you can expect the radial flux and sunspot number to continue to drop despite the likely massive uptick that is coming. So be prepared, folks. There is going to be a big uptick in solar activity coming, and it's likely to be coming soon. By the way, if you enjoy the content, consider becoming a member of the Smash Team to support the channel at smashomash.com/Smash Team. It's our subscription services site, which we launched back in October of 2021. The best value is the Gold Annual Paid-Up subscription, as it does include complimentary merch. It's almost like getting 4 months of a Gold membership for free. You can also get an at smashomash.com email address. If you join at the Gold level, just drop Smash staff a line. She'll hook you up with an email address if you've joined at the Gold level. So that doesn't require a 1-year membership. Even a 1-month Gold membership will allow you that. Plus, you can read about the plausible mechanism underlying the solar sunspot cycles. If you'd like to find out about that, smashomash.com/Smash Team. We are still on Patreon. You can find links below the video, as well as on the homepage at smashomash.com, the official homepage of the Smash News Network, least busted name in news. And welcome to the Neo-Renaissance. Congratulations on realizing the channel exists. You can also find links to the Hemp Lucid shop below the video. So check that out if you'd like to try out some CBD products, or perhaps some mushroom gummies or immune stacks. There are body balms, lip balms, all kinds of things, even CBD for your pets on the Hemp Lucid shop. Enter the promo code SMASHOMASH to save some dough on checkout at hemplucid.com. Shout out to Hemp Lucid. Shout out to everybody who's picked up some products. Today's featured merch item is Pick 2 Project Management Facts. Because, well, no project is cheap, fast, and good. So this is designed for smart project managers and perhaps as gifts to hacky project managers. No project is cheap, fast, and good. So pick 2. If it's going to be fast and cheap, it's also going to be bad. So that's not really recommended, right? If it's going to be good and cheap, it's going to be slow. And last but not least, if it's going to be good and fast, it's going to be expensive. So pick 2. It's either going to be expensive, which is fast and good but not cheap. If it's slow, it's also going to be cheap and good. And if it's bad, it's going to be fast and cheap. Don't do it. And let's see what's going on in terms of volcanoes. And a quick public service from a quick public service message from Smash Staff and I at massive personal risk and expense. Please do not pole vault the caldera. No matter how bad things seem, don't worry, folks. They can get worse. However, our finest days lie ahead. So if you're going through hell, keep going. Here's what volcanoes are erupting. Yeah, volcanoes. Shivaluch is producing a 15,000-foot ash plume over Kamchatka as it explodes. It's a flight level 150. Bezimiany also exploding. Flight level 150 from Bezimiany as well. So two significant volcanic explosive activities happening there on the Kamchatka Peninsula. Lubitolo and the Lesser Sunda Islands also exploding. Flight level 070. It's a 7,000-foot ash plume. Merapi continues with intense activity. Please do not hang glide over the caldera. Semaru also exploding. Flight level 140, 14,000-foot ash plume. 19,000-foot ash plume from Popocatépetl in central Mexico. Fuego in Guatemala exploding. Flight level 160 over Fuego. It's a 16,000-foot ash plume. Volcanic ash not seen in satellite. That does not mean Nevado del Ruiz is not erupting. Please maintain a radius of safety. Sangay exploding. Flight level 190 over Sangay. Sporadic emissions from Revenador and unable to detect Sabancaya either. Let's see what earthquakes have been shaken. There's your 90-day bar graph. Again, we do have a bit of a 7-magnitude earthquake drought happening here. And keep in mind, any earthquake could be a foreshock. This earthquake could be a foreshock. It is the largest of the past 24 hours. It was a 6.1 off the coast of Chile. So that was near the surface. That was at 11.6 kilometers estimated depth. The time was 17:33 yesterday afternoon. 6.3 magnitude quake there. Not a 6.1. 6.3 magnitude quake there off the coast of Chile. So we'll report on earthquakes over a 5 magnitude. Again, that one came through at 17:33 Universal Time yesterday afternoon. The Benin Islands there, south of Japan, had a 5.4. That one came through at 5:52 Universal Time this morning. And that's it. Only 2 quakes over a 5 magnitude. And again, a quick reminder, any earthquake could be a foreshock. Let's get back to space. Here's the closest star in ionized helium. The GOES-R, 304 angstroms wavelength. And a quick note here, 304 plus 131 angstroms from the GOES-R is a fantastic composite. That's ionized iron and helium. And it's great at showing bright active regions. Let's take a look at some stats here. The 10.7 centimeter radial flux, now all the way down to 140 solar flux units. There's the 1-year graph of the radial flux represented by this black line. The red line below it is a sunspot number. The pink is the 30-day Wolf number. That's an average of the sunspot number. And then we've got the blue line. That's the AP, the Potsdam AP, which is an average of earthly geomagnetism. Space Weather Enthusiast Dashboard is forecasting continued geomagnetic unrest into tomorrow, April Fool's Day. Don't be an April Fool and forget to press the like, subscribe, and share buttons. Also, leave us a comment. We've got a significant high-speed coronal hole wind stream currently striking Earth. We'll get to that data here in a moment at the Smash News Network Least Busted Name and News. So, not expecting any major fireworks here from this coronal hole high-speed stream. It looks like it has somewhat peaked out. Again, we'll get to that in a minute. First, Earth's magnetic moment from space. So here are the past 4 hours of Earth's magnetic moment from space. Represented here by the Space Weather Modeling Framework is the magnetohydrodynamic pressure surrounding the planet. There's plasma out there, and it's trying to reach static equilibrium. as Earth's magnetosphere interacts with the solar wind. That's the past 4 hours of Earth's magnetic moment from space. Here are the past 4 hours of Earth's magnetic moment from the ground. And we're showing North America here because we did have some nearly geomagnetic storm conditions there, right in between the realm of geomagnetic unrest and geomagnetic storm. The past 4 hours here of North America's changes to its B field here in the north part of the planet there. Some fairly high likelihood of aurorae there, stretching decently far down into the U.S. Also, Earth's magnetic moment from the ground here represented on the full Earth map, the flattened, highly distorted map view there of the full planet. Croissant Earth represented in a giant rectangle. That's the past 4 hours of Earth's magnetic moment from the ground. We showed you it from space and the ground. Let's get into some more data here. The KP index currently at only 3, so we've seen things calm down here significantly. Made it almost to 5 there at 4.67. Now we're down to a KP3. And if you're a new viewer, thanks for tuning in. Congratulations on realizing the channel exists. The planetary K index is a measurement of global geomagnetism. It's an average of Earth's overall geomagnetism. And let's take a look at the real-time solar wind as we've got some interesting parameters happening there, measured out at Lagrange point 1, currently by the ACE spacecraft. So current conditions are very diffuse solar wind here, at only showing up as only half a proton per cubic centimeter. You've got to take 2 cubic centimeters to find 1 proton. That's very diffuse for solar wind. Solar wind speed here quite high at over 600 kilometers per second. It made it almost up to 700 kilometers per second for a brief moment here. I see a reading of 685. And we see the magnetic field weakening. So it only got up to, it did get to 9 there, 9 nanotesla, not super strong. There was a solid negative BZ signal. That's this red line. That is the vertical component of the magnetic field. And that does lend to more geomagnetic storm conditions on Earth as it lends to current being induced. A negative BZ. So anyway, this is pretty close to what we forecasted. As you can see, like we said yesterday, you can see this drop in the solar wind density and an uptick in the solar wind speed. It looks like it's leveled off here. So we're seeing the plasma temperature also fairly consistent. So that's the current situation. A coronal hole high-speed stream continues. You can expect this to continue for another 24 to 36 hours, as those are transequatorial coronal holes causing that, and they are indeed sort of long. They're longitudinally long. We'll show you those in a minute. Next, the GOES magnetometers here, and seeing some sawtooth readings there of Earth's magnetic field there by the GOES 16 and GOES 18 at their geosynchronous near equatorial orbits. Also some maneuvering happening there. Those arc jet moments are plasma produced by their thrusters as they maintain that geosynchronous near equatorial orbit. And let's take a look at the heliospheric current sheet next. So that was earthly data. Here is some heliosphere data. This is the polarity of the current sheet. So Earth remains in a south pole current sheet. There is a north pole current sheet headed this way, depicted in green, as you can see there. Still a few days out here, and sudden activity could indeed change that. And if you're familiar with the top view ecliptic plane field plot, it could be the most important data set that we have to predict incoming space weather. I mean, like days in advance. Next, our line of sight field plot. Here's the sun's B field depicted in blue, north solar polar field in green, south solar polar magnetic field in red. Again, Earth is solidly in a south pole current sheet at the moment. And here's our line of sight coronal hole plot. I would also note that we've got some North Pole oriented coronal holes rotating in here, way down toward the south. We've also got a North Pole coronal hole remaining at the heliographic North Pole. So that indicates there's still a significant way to go to get to solar maximum. And let's take a look at coronal holes here. Let's reanimate this too. We'll take a look at coronal holes from the SDO 211 angstroms wavelength. So again, the last image here, there's the latest. We've got some North Pole coronal holes down here in the southeast. We've got a North Pole coronal hole up here at the North Heliographic Pole, and the rest of these are South Pole. Get off the screen. Thank you. All right, so there is our imagery from yesterday plus today. 211 angstroms wavelength. A great wavelength to view coronal holes, and let's look at the second most important feature of solar sunspot cycles, or solar cycles, because remember, folks, sunspots are magnetic in nature. They're magnetism at the photosphere level. Coronal holes are magnetism at the coronal level. Kind of important to understand that. Sunspots are at the photosphere. Coronal holes are in the atmosphere, 2 layers above. The layer in between there would be the chromosphere. And there's certainly a lot of interesting chemistry and other activity happening at the chromosphere level of the closest star. Let's move to sunspots. Here is the current situation. We can expect at least one new named sunspot group down here. That'll be 3268 if no other groups form or are named in the meantime. Let's take a look at sunspots here from the SDO once again. That is yesterday plus today's intensity gram. And again, most of those groups there are stable, and we'll see a diminishing sunspot number once again today as a bunch of large groups are setting. There still is a significant likelihood of solar flares down here and more so up here. Keep in mind those are both diminishing as those groups are setting and getting farther and farther away. The plasma that is suspended by those sunspots certainly still capable of producing large flares. And let's take a look at energetic particles and solar flares. So no new relativistic particles here. We did see a tiny spike yesterday caused by one of those solar flares, or at least associated with one of those solar flares, since the relativistic particle flux could have caused the flare. So since it's, in the realm of physics, we try not to say caused unless we actually know the cause. So, a solar flare and a coronal mass ejection, they're different phenomena. We're not going to say that the one causes the other one unless it's a sure thing. I mean, a lot of people sort of think that coronal mass ejections cause the flares, not vice versa. So anyway, no new spikes in the proton flux since this little uptick yesterday. That wouldn't have caused very much of an effect at all on Earth. Probably no polar radio blackouts from that. Flaring has been diminishing as well. Largest flare of the past 24 was this M class, but in the past few hours we did have a C class, a C 4.28. Peak flux was 910 this morning. And here's our 131 angstroms wavelength from the GOES-R. Again, the sun quieting down, which is, by the way, not an indication that it is a grand solar minimum. That's just utterly ridiculous. Remember, folks, extraordinary claims require extraordinary evidence. And if all of the data, all of it, refutes your hypothesis, you should probably abandon your hypothesis because, folks, your credibility might not ever come back if you sell out your credibility. So here's a star chart, and we're taking a look here at what's going on overhead of Lehigh Valley. Since your star chart might look different than ours, maybe you're at a different latitude and or longitude than we are here in Lehigh Valley, Pennsylvania. Head to skyandtelescope.org if you want to put in your own star chart. And we're coming at you this morning before the sun peaks over the horizon. If you're up before dawn, you might see Saturn. That bright object near the ecliptic there, that would be Saturn. About to move well, currently in between Aquarius and Capricorn. I think it's currently in the constellation of Aquarius. If that means something to you, great. And a quick note here about cosmology. We do have an interesting story here about an optical light outburst. And what's significant about this is that it's very flat. So most of the times when we see a large explosion from a star, it's kind of like spherical in shape, right? Like a, quote, supernova, end quote, explosion typically has a spherical shape to it. This fast optical, it's an FBOT. It's a fast blue optical transient. Fast blue optical transient, an FBOT. And this is extremely flat. In other words, it's like the equatorial disk has material coming out of it, but no material coming out around the poles. It's a very flat explosion, and these are kind of rare in space. So this is the flattest one yet observed. So we may have covered this similar story a couple of years ago here, the aspherical cow. That explosion is about the size of the entire solar system. You can find an article about it on SciTech Daily. It's located 180 million light years away. The fast blue optical transient, an extremely flat explosion where it's like only the equatorial plane features the explosion. No material coming out anywhere near the near the polar regions, right? No kind of material in those areas, only around the equator. So a very flat explosion there from that star. Again, SciTech Daily has an article about that. And let's do a solar system forecast. Here's where stuff is now. We'll advance this 1 week. And we're 6 days from a full moon here on this lonely side of the solar system, devoid of other planets. Which brings us to coronagraphs. So here are yesterday's coronagraphs. There was a CME kind of early in the morning. It was happening when we streamed yesterday's video. It does not appear to be earthly directed. Here are today's coronagraphs. Nothing too exciting going on there. Let's also take a look at stereo A because we show it daily, because you never know when you could miss something. Sometimes you overlook the fact that there's missing data on one of the coronagraphs or something like that. You never know. So we always, because folks, if you don't look, you're certainly not going to see things. I know it sounds complicated, but we've had ridiculous arguments about space weather in places like Facebook with people who think that they're gods of space weather, and they don't have to look at the coronagraph to figure out whether or not there's a coronal mass ejection. So anyway, some great imagery there. That CME is off to Earth's west and south, not earthly directed. And I think our 24-hour coronagraph images will corroborate that. So things quite calm here. Let's get in one step closer. There is your 24-hour composite. And again, that roll of the GOES-R there, that's not the sun rolling, that's the spacecraft rolling. As you can see, the coronagraphs remain stationary. Anyway, some CMEs happening there, not earthly directed CMEs. And let's get to filaments. So the shack filament remains intact. Although part of it blasted off, we showed some fantastic imagery of that. It even appeared on our thumbnail. The shack filament. That is a good one. And we've also got some other very large filaments in the Earth-facing portion of the solar disk. Filaments here, filaments up here, filaments here, filaments down here, and filaments over here. Likelihood of coronal mass ejections remains at nearly 100%. And here's the past 24 hours in GOES-R, 171 angstroms, We'll also show the last couple of hours in the GOES 16 because we might have missed something while we were creating this broadcast. So we do have this huge prominence happening over here. Again, we still do have a high likelihood of large flares, especially in this area right here. So that possibility has not gone away yet. You can still expect another 24 plus hours of high likelihood of large flares on the western limb. Besides that, likelihood of large flares not so high. The rest of those groups are fairly magnetically simple. So that brings us to our bonus features segment. Let's talk about charging hazards. On our satellite's community dashboard, we do have some significant surface charging happening here over Mexico. Those surface charging hazards are caused by low-energy electrons that build up on the outside of spacecraft. That'll be moving into the Central Pacific Ocean shortly. Next, our GOES electron flux here, quite a bit higher than expected. So we've got quite a high-speed coronal hole wind stream going on. It's got a very low density also, apparently, and electron flux here, again, much higher than expected. You can see some quite different readings there from the GOES 16 versus the GOES 18. The GOES 16 represented by the blue line, the GOES 18 represented by the red line. And here is your relativistic electron forecast by NOAA. Actually expecting an uptick tomorrow already. I suspect that tomorrow's electron flux will be quite similar to today's. Make sure you watch tomorrow's daily space weather video to see if I was right. There's the 1-year graph to put it all in context. Much higher than expected levels of electron flux during this coronal hole high-speed stream. Next, we'll show the F-layer of the ionosphere. That's the 300 kilometers approximate location of the F-layer. One slice of the upper thermosphere here shown in vibrational frequency. The gas is very diffuse, but it's vibrating at millions of vibrations per second, otherwise known as megahertz, which is what is depicted on this imagery. We certainly do see some high-frequency anomalies happening. Do we see any low-frequency anomalies happening? Well, if you're not sure, don't worry. We've got the anomalygram as well. This is anomaly in megahertz from a 30-day median. We show it daily on the channel. If you want to know what was happening a year ago, well, we've conveniently placed our daily space weather videos in a playlist at youtube.com/smashomash/playlists. So major low-frequency anomalies happening there. It looks like some plasma making it down into the earthly system. You can see some polar low-frequency anomalies happening there at both poles. So likely some material from space making it into the earthly system. That's effectively like a cooling down of the ionosphere, where we'd expect matter to be more dense, hence a lower vibration, a vibrational anomaly in the low frequency range, indicating that there's more material there, causing it to vibrate more slowly. The opposite of a heating event. It's essentially a cooling event caused by more material. And keep in mind, folks, the layers of the atmosphere are inverted. In other words, the Earth's troposphere is warmer at the surface and colder at the top. At the stratosphere, it's colder at the lower portion of the stratosphere and hotter at the top, and so on and so on. There are temperature inversions happening at each layer of the atmosphere. Anyway, that's what's going on in the ionosphere. Here's your latest image. That's 1030 Universal Time ionogram and 1030 Universal Time anomalygram. We've also got the total electron content. We're going to show you 3 different views of that. The free electrons from your GPS satellite down to your handset. This will show you the most likely places to see GPS errors. It's about a 12,500 mile run from your GPS satellite down to your handset, and a lot of free electrons can cause signal refraction, aka GPS errors. These are the most likely places for them to occur. We'll let it play through a second time here. We've got some decent anomalies happening there. Some nighttime GPS errors likely around the equator, and some random GPS errors likely to be happening around the polar regions. Here's North America's 10-day anomaly. That is anomaly from the 10-day average. And it's showing you 1 day of activity there. So that's your North American total electron content 10-day anomaly from the 10-day average. And we'll also show just the U.S. And we'll close out our space weather portion of the video with some high-res imagery. So again, this area up here is just a plage, not a sunspot. Let's go on a sliding tour here. And as we come down toward the equator, no sunspots over there in the east. But in the southeast, there is, oh boy, that thing's looking weak. Okay, so we've got two new likely groups out here. So this one's looking very small. That is indeed a sunspot. I see a dark umbra. This one here, much more significant. Let's take a look at the fields of that one. And that is looking like it is a North Pole umbra, which is a bit unexpected. I suspect that's actually a South Pole umbra, but we'll have to keep an eye on that throughout the day today to see what's going on with it. This one up here, probably only an alpha class sunspot. Let's just show the full disk view. Again, significant diminishment of solar activity since yesterday even. So another big downtick happening today. Expect the radial flux to drop precipitously along with the sunspot number. And no, the sun is not shutting down. By the way, if you enjoy the content, don't forget to follow us on Twitter. And don't forget to press like, subscribe, share, etc. on YouTube. We need the assistance of people like you to get the content onto people's screens, because the videos don't seem to be recommended by YouTube. Why? YouTube likes to promote propaganda, disinformation, fraud, and nonsense, and it likes to suppress facts. So maybe too many facts on the channel. Terribly sorry about all the facts that are expressed on the channel, YouTube. Again, thanks to our YouTube subscribers for tolerating the pathetic and putrid censorship on the platform. Thanks to our new Twitter followers. We're pushing 400 whopping followers on Twitter. Wow, isn't that exciting? We've only been putting up tweets and original content for over 4 years now. We started our Twitter account back in 2019 for business purposes. And of course, the shadow bans, aka deboosting, continue on the putrid Twitter platform. But follow us over there anyway because, well, there's information you won't see anyplace else. You can also find a link to the free mushroom gummies giveaway if you want to try some free samples from Hemp Lucid. You're interested in the mushroom gummies for stress, sleep, focus, etc. Check them out. And let's get to meteorology. So we'll transition from space to Earth by looking at the space layer at nullschool.net, as we do have some likely aurorae. There's the Aurora Australis, and there is the Aurora Borealis, likely oval, the auroral oval as it is called. And let's switch to the jet streams. So here are the 250 hectopascal winds of the eastern world. Shout out to our viewers from the eastern world, and we need more viewers in this oval, since there are over 2 billion people in that oval. And please leave a comment if you're viewing the video from the middle or far east. We highly doubt it. We highly doubt you're able to see the content anywhere, much less in these highly populated locations. So those are the jet streams of the east. Here are the surface winds. of the east, surface winds of the west. It's windy in the central part of the country. Check it out. It's a windy day in Texas. West Texas has a wind out of the west, and central Texas has a wind out of the south. Here are the jet streams of the Americas. Jet streams of the central world, Africa, Europe, and the Middle East. And last but not least, the surface winds. Shout out to our viewers from all around the planet. And if you're new to the channel, make sure you leave us a comment and let us know where you're located. Perhaps we'll even do a custom weather forecast, especially if there's something severe headed your way. Here are the clouds and fog over the Americas. As the sun slowly rises over the Atlantic. We hope you're not frantic because you've been listening to nonsense and utter hacks about cosmology in the realm of space weather. Next, our weather.gov map. If your location's lit, click your location. There are too many counties for us to cover there. And there are some blizzard warnings showing up. Yeah, blizzard warnings in especially South Dakota. Weather.gov is the location for your government weather station. And if your location is lit, click it on the map. We only zoom into about the lower 48 view. So let's take a look at the likelihood of precipitation here. This is our pressure and precipitation forecast. We're only going to advance this 3 days. So this was not available when we did show prep, so there's a 3-day forecast. Right now there's ice already showing up in South Dakota, Nebraska, Minnesota, and Wisconsin. That's going to diminish rather quickly. And then a strong low is going to form around the Iowa-Minnesota border. And that's going to move off to the northeast. So that's the next 72 hours, and in about 3 days we're going to see some severe storms kicking up once again in places like northern Louisiana, southern Arkansas, and Mississippi. Just so you are aware of that. Now let's show the... let's don't show regions. Let's show the total accumulated snow depth, total positive snow depth change. Okay, there we go. So there is a 72-hour snow forecast based on a GFS model. And let's go to windy.com and look at the GFS versus Euro models. So there is the next 3 days of new snow. That's the Euro model. And then here is the GFS model. We'll also show rain accumulation for that same period. So there's rain accumulation for the next 3 days on the GFS, and there's rain accumulation for the next 3 days on the Euro model. One of the great features of windy.com is new snow and rain accumulation. Next, looking at lightning, and there is some significant lightning here all the way from Texas up to Lake Michigan. Some possible thunder snow happening there. That's our NASA GOES lightning mapper. And let's check a real-time lightning map to see if there are any terrestrial strikes, and indeed there is quite a bit of activity here. So some new lightning strikes there in the southern portion of Lake Michigan. Also some active cells there in southeastern Minnesota and east of the Mississippi. Nashville just having a lightning strike there. Little thunder rolling in at Nashville at the moment. So that's our real-time lightning map. If you've never seen it before, lightningmaps.org. I've used it to figure out if I should wait in the car for the severe thunderstorm to pass or if the lightning strikes are nowhere near me. Remember, folks, if you are able to hear thunder, you are able to be struck by lightning. Of course, you could be struck by lightning even if you can't hear thunder, because, frankly, a lightning bolt can just come out of nowhere. And, of course, that'll cause people to think that it's a directed energy weapon or some other nonsense like that. And let's continue on to our final 3 frames, the U.S. Doppler radar map. And snow will continue to fall into April. So there's what's going on in the lower 48. There is clouds and fog. And there is the water vapor map. Here's a recap. That is quite a bit of moisture east of the Mississippi. There it is in 3.9 nanometer infrared radiation satellite. And there it is in 6.19 nanometer radiation water vapor satellite. Hope that helps. Hope you're able to forecast your own Earth and space weather. Thanks for tuning into the Smash News Network, least busted name in news. And may that solar wind be at your back. Also, don't forget to visit the links here and here and here.